This will be the second part of the lecture on theory and causality for Research Methods course. As we discussed earlier, a scientific theory is a systematic body of ideas about a particular topic that can fulfill the different goals of research, so organizing, explaining, predicting phenomena. So a theory then is a set of ideas that will include these key constructs that we've just discussed, and there's an organization to them, which means that in essence there tends to be accounts of how these different constructs are actually connected. So a causal theory might provide an account of why it is that there's a dependence or connection between multiple theoretical constructs. So we talked a little bit about the idea that at some level the thing that is connecting these two or three or more constructs is almost like a black box or a mechanism. So there are mechanisms in between these different constructs that say how one relates to another or how one produces another. Probably in your head right now you have a lot of lay theories about how the world works. Ideally, through your education here at UMass, you've also gotten some non-lay theories, some actual scientific theories. But one thing to keep in mind is that many of the things that we believe about to be true about how the world works are sort of informal common sense explanations that may or may not be accurate. In fact, I would encourage you to watch the TED Talk about babies and whether or not they actually are good empirical scientists on that is listed on the Google Classrooms account, to consider whether or not, in fact, the babies are making the correct inferences or not from the empirical data that they're observing. The theoretical system, then, we can think of as consisting of these constructs. Let's just call them for now A and B. And we already know that in addition, we're going to have this measurement step from our previous lecture that's going to connect this construct down to an independent or dependent variable. We're using the variable language, and we tend to think about independent and dependent variables when we think about causality. So in other words, what we're often interested in is a connection between some construct, say intelligence, and some other construct, say success in future life. And then we think about how those things are connected, but we have to go and measure. So then we would say, okay, intelligence we're going to measure with our IQ test or some other type of thing. And success in life we might measure by income, or we might measure by self-reported happiness. And obviously, to some extent, these this relationship between these variables might vary depending on how we measure them. But it's also important to keep in mind that even at the connection between the variables where we start to actually do the scientific research process, we have to distinguish between a causal relationship between two variables, i.e. there actually is a mechanism that links the first variable to the second variable. So in the case of height, for example, it's been shown that height can predict earning potential for males. Height at age 16 can predict earning potential for males. And part of what we have to ask ourselves is there a mechanism that is connecting whatever it is that males experience at age 16 with their future earning potential? If we don't think there is one, there might be a correlation. They might co-vary systematically, but there might not be a mechanism, in which case it's not necessarily a causal relation. So just a quick note about vocabulary. In the previous slide, we looked at the independent variable and dependent variable language, but we might also see that language said as something like cause and effect, stimulus response, if you're getting very behavioral, antecedent and consequence, if you're thinking about logic, or also explanans and explanandum, manipulation, if you're thinking about an experiment and the outcome that you're measuring, or again, with logic, premises, conclusion, and if you're getting really mathematical about it, we're just going to call them X and Y. So it may be that in these future lectures or in the books or articles you're reading, you'll see any of these terms used to refer to this basic idea that there's sort of one variable on one side and one on another, and we're looking at the relationship between them. Now, I'm talking here, by the way, primarily about this bivariate or two-variable case, but in fact, we're going to see that the multivariate or multivariable cases will become far more likely that we're going to be exploring as we move on. It's just simplest to introduce with only thinking about two variables, even though the real world, of course, is never that convenient and almost never works like that. So a nice example here of what a covariant relationship looks like when we start to look at actual data. You will see that along the x-axis, we have graphed runs. So this is the number of runs hit by all Major League Baseball players, sometime in the 1990s probably. And their salary is graphed along the y-axis. So every single player who played in whatever year this was, I think maybe 1994, probably we've got, yes, like Sammy Sosa and Barry Bonds way up high. But what you have is that every single player has associated with them both the number of runs they scored that year and the salary they were paid that year. And so you just plot it the same way you did when you were in grade school. Their X value and their Y value, and each of these dots is a player. And what we can see here is there's a clear upward slope, right? The more runs a player scored in that year, the higher their salary. This is an example of what correlation looks like. So when we get to actually plotting our data, these are the types of things we're looking for. And in fact, one of the things that I want to stress throughout this class is that this visualization, the sort of looking at these relationships between different data points, is as important as doing any type of statistical procedure on them. It's one of the reasons that I personally like the R statistical language, is because you can plot so very nice looking graphs in a way that you can't always do in other languages. So again, just to reiterate here, our X is the runs and the Y is the salary. So again, cause effect. Though of course it's pretty hard for runs in a single year to cause, in fact, the salary in that year. So if we really wanted to think about causality, we'd probably have to go runs, 5 years before, or the year before they got their contract, right? Because other than that, we know it's correlation, but we can't necessarily say it's a causal relationship without making some inferences about how runs this year was actually affecting. It can't affect something that occurred in the past. So it would have to be a proxy for what the productive potential was assessed to be at the time the contract was given. Now, I've talked a little bit about mechanism, and I mentioned this earlier, and I really want to stress this. Suppose we have a question like, why did the pot of water boil? Well, that question could be answered in a lot of different ways. So if you're in science class, you might think about sort of elementary science. Oh, it reaches its boiling point, right? So this is my son in chemistry right now. It reached its boiling point of 100 degrees Celsius. Hopefully, if you're in a more advanced science or applied mathematics class, then you're going to start thinking about phase transitions and percolation. The same idea of boiling point, but now you have gone more in detail and depth. However, if you're thinking about sort of directly, why did that pot of water, if you come into a kitchen, you say, why is that pot of water boiling? Well, somebody turned it on. Who turned it on, right? So were you hungry? Is it breakfast time? Oh, well, we're living in Ireland, and Ireland is quite a traditional breakfast food. However, if you came to a kitchen in America, you would often not find a pot of water boiling, but you might find a pan heating up to fry eggs, or you might find just a cold bowl of cereal. However, you might also be thinking, oh, well, what about whether or not these people actually even had a clean water supply to boil water? So there's lots of different ways you can address the question of why did the pot of water boil. And so in general, one of the things that we want to be careful about is the why questions, unless you're sort of quite specific, can get quite broad. Even though we're often interested, the why is a signal for sort of this, very much like the how rejoinder, that it's a signal for we're looking for a link between at least two or more things, or we're trying to choose out of the many possible independent variables that might have caused a single dependent variable, which was the primary cause. One thing I'd just like to mention, of course, as an advanced concept, is that as we're going to be talking about in more detail, statistics is quite a bad, it leaves something to be desired, shall we say, in terms of being able to tease out the causal relationships between variables, especially when we have a lot of different causes. So this observational type of work that we're doing, say in surveys, as opposed to experimental research, but if we're doing surveys, if we're doing text analysis, if we're doing other types of things that are purely where we just observe things happening, but we aren't going in as a scientist and actually sort of directly manipulating the things that are going to happen to our, and randomly assigning what's going to directly happen to our subjects, then it's harder to figure out what's going on in a causal sense. There has been some great work, though, if you've heard some about the causal revolution, that's a little bit iffier. There's attempts to sort of statistically get some purchase, but this combination of philosophy, logic about causal nets, or networks of relationships, and how we can use a combination of logic and math and statistics to sort of tease out what causes what through this causal net process. If you've Judea Pearl is a person who's been quite active in this at Stanford. Richard Shines and some other people at Carnegie Mellon, and actually here on campus, our own David Jensen has been quite active in this work on directed acyclic graphs, or the idea that you use this combination of observationally derived statistical relationships with experimental data at points to sort of, in essence, tease out. You can't, from a single statistical study, say for sure what does X cause Y, but you can say all the X's that don't cause Y. And if you put enough of it together with some experimental data, sometimes you can get down to a limited number of models in which X might, a limited number of models that accurately represent the data that you have. Again, it's an advanced topic, but it is sort of fun. If you go to the Carnegie Mellon website, there's a nice little application you can play around with that help introduces you to the idea. And you can also be on the lookout at ISSR for presentations by our own David Jensen. So the sort of simpler version of all of this is to think about different ways that three or more variables might be related. And in the sort of classic three that we think about are mediation, moderation, and spurious correlation. So I'm going to explain all these in detail, but first let me just quickly define them. So a mediating variable is one that is going to, in essence, sit in between and account for why it is that there's a relationship between our independent variable and our dependent variable. A moderating relationship is going to actually affect the strength of that relationship. So it'll be a third variable that makes the relationship between the IV and the DV stronger for some people and weaker for others. And a spurious relationship exists when there's no direct causal connection of any sort, or even an indirect causal connection, but instead there's a third variable in the back that's causing both. So let me give you some examples to clarify these three types of relationships that can exist when we get beyond the bivariate case and we start thinking about the trickier three variable or multivariate case. So here we go. These are actual correlations that have been found in research. Married men live longer, and people with college education are more likely to turn out to vote. So let's consider first the issue of married men living longer. You might say, okay, well, all I have to do then if I want to have a longer life is just get in a marriage. It doesn't matter what type of marriage necessarily. I'm just going to go get married. There you go. I'm going to live longer. But it turns out that it's not in and of itself probably marriage that has this positive effect, right? We think of it being more what might happen to you during marriage. So this would be an example of mediation, where in fact part of what happens is that men who get married tend to adopt healthier habits. So maybe they stop staying up late, they start eating not just junk food, but maybe having more natural home-cooked meals. This was an older study. I've actually personally sort of wondered if there hasn't been potentially a change in this as if we've had more women work and also more men learning how to cook, that perhaps marriage is now having an effect as much on women as on men. I know, at least in my cohort, plenty of women whose husbands cook for them. So I think that this was an older study, but again, you can see how understanding the mechanism can help us then make predictions about how likely this causal or this correlation between marriage and longer life is, how likely it is to uphold when conditions on the ground change that might affect the mechanism, like whether or not men were actually living unhealthy before, or whether or not there'd been an upsurge in men learning how to cook and men not going out and staying late at bars, etc. Another example of a mediating relationship between education and turnout is actually based on some of my own research, where I made an argument that in fact it's not having a college education. It is belonging to a certain type of social world. So if you remember, one of the examples that we talked about in class last week was this idea that perhaps the function that had once been served by a high school education is now being served by a college education. And in fact, that's very consistent with the argument I'm going to make here, which says that what's really important is that you belong to a larger, more loose-knit social world where norms more easily diffuse or spread. So to show you then some exact data on how one might prove that mediation is taking place, there are fancier statistical ways. This is a very simple way that you might be able to even do in this class. You'll learn enough in this class to do it. Is that we could look first and we say, okay, if we just look at the bivariate relationship, and so here we don't have a scatter plot, what we instead are going to look at is the average turnout rates by the amount of education that we have. And as we can see, because we can look at the little confidence bars, you can see that people that have at least a college degree, college and graduate school are the same, are significantly more likely to turn out because the error bar doesn't overlap the top of the some college bar, and it certainly doesn't overlap the high school degree or no high school degree bar. So this is from the 1985 GSS, and we can say here that there's no doubt that having a college degree or even having some college makes you far more likely to turn out than not. However, there is another variable that was measured on the 1985 GSS, which is whether or not you named at least one friend who had a college education. And so here we can see that of the people that named at least one friend with a college education, regardless of their own level of education, they named on average 4 people that they discussed politics with instead of on average 3 people that they discussed politics with. So again, there's a simulation that can be run showing that if we assume that people are doing what their friends are doing and if they're in a larger network, then more people are going to turn out regardless of how likely people were initially to turn out once they've sort of paid a little bit of attention to what their friends are doing. So what's important here is that in essence, whenever we go back and we redo the graph that was in the first graph that we saw, which was turnout by individual education, and we now split the people who are in this, who name at least one college degree friend and those who don't, then we can see that there's no longer an effect of your own education level. What really matters is if you have at least one friend in the multi-education world, which means you belong to this larger, more loose-knit social world. And thus we can say that in essence, education is not having a direct impact, but instead an indirect impact that is mediated by this social world. Because in essence, getting a college education is one of the major entrees into this larger, loose-knit social world with multi-educational background, but it's not the only way in. So some people who don't have it can also get in. So the mechanism is mediating, and education is not directly causing turnout. Now, a quick word about spurious correlations, which is another example besides mediation. So here we have a relationship between ice cream and drownings. And what do you guys think? My grandmother would have said, well, of course, that's because you jumped in the pool right after you ate and you didn't have it time to settle, so you're going to drown right away. But perhaps you don't agree with them. Think for a second, what could it be that causes this observed higher incidence of ice creams that goes up with more drownings, and whenever there are less ice cream bought, then you have fewer drownings? If you thought to yourselves, they both occur in summer, more people buy ice creams and more people are swimming, therefore more drowned, then that would be right. That would be a great example of a spurious correlation. It's not the case that swimming on a full stomach is necessarily causing everyone to drown, but instead summer is causing both more people to purchase ice cream and more people to drown because they're more likely to be swimming. How about cities with more police officers actually have a higher crime rate? Now, to some extent, one could say this is the wrong way around. It's really cities with a higher crime rate have more police officers. But again, something to keep in mind is that really population density is driving both of those. Both of those. So if you have a lot of people living in a small area, it's going to tend to both increase crime and increase the amount of policing that is needed, simply because you just have more people in the same area. So the police officers per capita and the crime rate per capita are going to tend to go up. Finally, let's give a few examples here of moderation. So in the case of moderation, it is in some ways one of the trickiest ones to remember And not just because it sounds a lot like mediation. And trust me, I will advise you, before you ever answer a question on mediation and moderation, go check your notes. They do sound a lot alike. Until I started teaching this course full time, I often found myself, I had to go back and check my notes on this. But moderation is something where, in essence, the slope changes. So in all of these graphs that you see to the right here, these are the equivalent, say, of those early, that scatter plot that we saw, but now we've got sort of a line graph where, so in the first one we have support, the proportion of people who want to cut government services, and the level of political awareness. And what you can, in essence, see across here is that as people's become the most politically aware Democrats really want to cut services about as much as the least politically aware Democrats. So becoming politically aware isn't necessarily changing their inherent propensity. Sort of paying attention to elite political messaging isn't changing their inherent propensity to support the cutting of government services. For Republicans, though, as they start to pay more and more attention to the messages from their party's elite, their propensity to support cutting government services is going up significantly. In other words, it's not the fact that your party identification is directly predicting what your opinion on cutting government services is going to be. It's your party identification in combination with how much attention you're paying to your party elites, right? So Republicans, strangely enough, and it is sort of strange, aren't, if they're not paying a lot of political attention, they might call themselves Republicans, but it doesn't mean they're doing what we think of as elite Republicans as saying Republicans should do. They have to actually be paying attention in order to start to act like that, which is sort of one strike, frankly, against the idea that people gravitate to parties because of political issues. That might be true, but only if they're super politically aware. The same types of relationships, as you can see, are actually found in stuff on research on job guarantees, defense spending. There you can see Democrats are not quite as flat. What actually tends to happen is their support goes down for defense spending among the most politically aware Democrats, and the same with the Vietnam policy. This is out of John Zoller's book, the 1992 book, Nature and Origins of Mass Opinion, which is a classic in public opinion. And one of the interesting things he finds is that, in fact, with Vietnam policy, both Democrats and Republicans, even at the high awareness levels, were equally supportive early in the Vietnam War. It wasn't until the party elites diverged that you start to see this divergence between Republican and Democratic opinion. So those are examples of moderation. Anytime you see one group of people is acting different than another group of people, it means the variable that's causing the groups, whether it be political awareness or age or something else, is in essence changing the way this initial variable, in this case party ID, affects the outcome opinion. So that's the end of this lecture. Next up, we're going to be talking about how we look at validity, sticking within this theoretical system we've outlined.